Okay, so sure. We're going to do some exercises. These links are in the PowerPoint. However, one thing I noticed the first time I used this material is that these links take you to a set of problems, but they're random. So that's why I'm recording it right now. So if I click any of these links, we're going to do a few problems. But if you click on the link, it's going to be exactly the same problems, but they're going to be in a different order. Okay, so we're going to do them here, and we're going to do the solutions that you're going to have them here. But just to note that if you would click on the link, it's not going to be it's the same problems, but they're random. Okay. These set of problems is just to practice the concept of Kirchhoff's laws. Okay. Yes. So I'm gonna let's do the first set. These are a set of problems where we have a situation and then we have a multiple choice options. I'm going to see if I can make this. There we go. Okay, so we're going to go through each of them. I'm going to give you literally a minute to kind of read through it and see if you have an idea what the answer is, and then we're going to solve it. No, we're going to be doing it here. I'm just giving you 1 minute to read it and see if you guys. These first set of problems don't necessarily need calculations. These are just problems for us to review and understand the concept of Kirchhoff. So let's see. Let's look at this. Let's look at this situation. We've got a circuit that's got 3 elements: R1, R2, and R3, and 1 power source. How are the three resistors connected?
In series.
They're in series, correct. And there are 3 currents marked in each resistor: I1, I2, and I3. So they're giving us 4 options. And they're asking us, what can we say about those currents? So let's look at the circuit. If the 3 resistors are in series, then what happens with the current in series? They should be the same, because it's the same. Remember that the circuit's like a pipeline. It's the same pipeline. So if I have a current here that I'm calling an I1 that's going to R1, that's going out of R1, but it's going into R2, and then it's going into R3 and coming back to the power supply. There's actually just 1 current in that circuit because they are connected in series. Okay, and so there's actually 1 current going through the circuit, and this current is, we can call it I. So in this case, I is equal to I1, it's equal to I2, and it's equal to I3. So the answer would be D. By the way, when you guys are going to study for the exam, you can use these same links because since the problems are random or randomized, you can go through the problems again and you can, it can be kind of like a test. And I think there's other sets of problems there that you can in the same section. So this would be D. Okay. I think if I go down here, there's an option here on the bottom to check the answer. Okay. And actually, in all these problems, if you go here where it says at the bottom, stop, use hint, if you click there, it's going to kind of give you a solution. So you can use these links as kind of like a test for you guys to practice. And if you select the one that's incorrect, then you can go to the solution and it's going to kind of explain it. So we'll check this and yeah, it is correct. Why did you guys do these sorts of?
We would do that with
these sorts of problems?
and we would compete to see who's the fastest.
Oh, kind of like a, what is it called? A doodle or whatever. Okay, now I'm going to give you another minute for this one. Just look at that one. And now we've got more currents established there. And what can we say about these? Well, no, it's greater than. One thing that can help you out to know that. Remember that when there's a node, remember Kirchhoff's law that says that everything that goes in comes out. So if I have a node and I have one thing coming in and two things coming out, obviously what's going in has to be larger than what's going out. Okay, so kind of that's kind of a tip, kind of to try to understand.
What goes in is what goes out is larger than what goes in.
No, the other way around. So imagine again that you've got like a river and you've got a flow and then it separates. The separation is dividing it. So if I have one current going in and then it separates 3 or 4 ways or 2 ways, whatever's going out has to be smaller than what's
For
going in.
example, there are the current 3 would be greater and 2 de kilos no son iguales, entonces, or 3 will be greater than 4.
Yeah, but right now, well, let's analyze. Let's start analyzing because there's many combinations depending on how you look at it. Okay. By the way, but by the way, the students from a lot of students from 8th semester are going to be doing their Ceneval exam. They're really freaked out about that. Remember that there are certain tips when you do multiple choice. So one of the techniques for doing multiple choice is eliminating things that don't make sense. Okay, so yeah, let's write down things we know.
Okay.
And based on that, let's work through it. So first off, this section here, I'm going to draw it here. This section here, these 3 elements are connected in it's part of a loop, correct? And they're in series. The 3 elements are in series. These 3, R4, the power supply, and R1. So what can we say about I1 and I4? So these are things we know. Okay, we'll get to the answers in a moment. So I know that I1 is equal to I4. Okay, that's something I know. Now let's see other things I know. Let's identify this point here, I'm gonna call it A. This is a node, and this is a node as well, and I'm gonna call it B, okay?
Like, do you know that I1 is equal to I4?
Okay, because the red part that I drew, those three elements are connected in series. Whenever you have elements in series, their currents are always gonna be the same. It's the same path that's flowing through each of them. Now, let's look at node A and apply Kirchhoff's law. So what is going into node A?
2 and 3.
No, one?
and 4.
No, to node A, just, we're located just here.
Just one,
One, and what is going out?
2 and 3.
2 and 3. Now let's look at node B. So for example, going back to your question, Lisa, current 1 has to be larger than currents 2 and 3 because of that mathematical, assuming that the signs are correct. I2 is going out because if you notice the arrow, it's going outside. So whenever you see currents in a circuit like that, just kind of continue the line and you see if it, whatever the arrow is pointing, if it's pointing outwards, it's going out. If it's pointing inside to the point, it's going in. Now let's look at node B. What is going into node B and what is going out? 2 and 3 are going in. And that is congruent because we just said that I1 and I4 are the same. So 2 and 3 have to be smaller than I4. Okay? 2 and 3 have to be smaller than I4. So out of all of the options that we have here, first off, we're going to, which ones are we going to eliminate? We're going to eliminate A. This isn't, we're going to eliminate B. And we're left with these two here, C and D. Okay, so what can we? Oh, there's another detail here that we forgot to look at. The resistors. R1 is larger than R2, is larger than R3, is larger than R4. So let's consider that. Of these two resistors, which is the larger one? R2 is larger than R3. Okay, because of this part here. Are we understanding that?
Yes.
Okay, now remember the concept of resistance. The larger the resistance, it's more opposition to the flow of current. So the larger the resistance, the smaller the current. The smaller the current, the larger the resistance. So if R2 is larger than R3, then what can I say about those currents, about I2 and I3?
No, I2 is smaller than I3.
Because the larger the resistor, the smaller the current. Okay? It's directly proportional because of Ohm's law, correct?
Inversely proportional, because the higher the.
It's inversely, yeah. Mhm. Because of the, it's a version of current. So which option is it? D. I hope it's correct because it's very sad when I do a very, very long explanation and a multiple choice answer and it's not the correct one because my brain was on Monday. So let's cross our fingers. I'm going to leave that there for a minute before we, well, I'm going to scroll down, check the answer and go up again so you can draw it. So we're choosing D. I'm going to leave it there if you want, guys want to. Yes.
We don't correlate because they always show the incorrect and the correct thing.
Oh, darn. No, but I can fix that. Yeah, I'm gonna wait. I'm gonna.
So yeah, series and series of current is the same.
The way to remember it, series the current is the same until the current is separated or divided.
And Professor, if we didn't have that point about the resistors, if we didn't know that each one, if we assumed that they were all the same, would C then be correct?
Could be correct, but if we assume that the resistors are the same, yes. Yeah, because the current would be divided equally.
Professor, in this, in the Tesla, it's just the current, I mean, it's like they say.
Oh, the law that we're talking about right now is the first one, which is the current law. So right now, all of these exercises do the first law.
And
which
then
is-
the other one is.
Yeah, the other one, we're gonna do a set of exercises for the other one.
And in parallel, well, just the current is divided.
Divided. Okay. Can I jump to the next one?
Yes.
Okay. This is kind of what you were asking, Ricardo. Now the resistors are the same. Okay. Now let's look at this one. This is very similar to the other one. It's kind of the same thing that we're asking. There's a combination there of options for the currents, but there's a thing here that kind of helps us out. All of the resistors have the same value. So kind of try to do the same analysis we did with the other one and see what you get. All of the resistors have the same value.
Puede ser eso. Para visualizar. No, this will help me visualize.
Entonces, eso es una parte de eso. Que también tiene-
Aguanta.
Entonces, ya con-
Entonces, es que mira, I1 has a complement like I negative 1. El complement está en el otro.
I2 and I3.
Ya cuando sale este no.
Yes.
So I
I2 también tiene
is
su
equal
complement.
to I.
And I2 is equal to I3.
Cuatro no era nada, por eso es más grande.
No, el no. No, el I1 se separa. Tiene su parte. El I4 es más grande.
A ver, aguanta. Primero no. No
Entonces,
es.
es de- la de- Sí,
Aquí tenemos.
no, cada uno se separa. O sea, el I1 tiene su complement, el I2 tiene su complement. Y el I3 es igual a I3, entonces son iguales.
I see one note.
Entonces, es de-
Uy, son 5 y yo estoy
Okay, everybody. Shh. Yes. Label location.
Es que la I1 es un número, su otra parte estaba y no tiene está listo. So I just see it. Se reúnen otra vez y los mismos. Todos son complements menos la cosa.
Okay. Okay, okay, everybody, let's begin. So first off, let's do this. Let's do the same thing we did with the other one. Let's write down things that we know. So first off, 2 and 3 are the same. We know that because they're in the same, they're going in the same element. So I2 is equal to I3. Okay. Let's see what, yes.
Yeah, in this interior.
Not necessarily because, well, they're in series, but I2 is going into this resistor. And what's coming out? The same. There's nothing in the middle, or there's nothing branching out the current. Okay. And so whatever's going in has to be what's going out.
So we can eliminate D and A.
We could, let's go through these, and then we're gonna see how to which ones maybe don't make sense. Was that clear? The way you can literally do it is that, again, imagine it's like a racetrack. So you're literally drawing the path. So if I'm here, I'm doing this. Is there anything that's separating the line? No. And so everything that's pink is the same. So in this case, I2 and I3 are the same. Yes.
Like the resistor 2 and 3 they are parallel,
Yes.
but we're talking about the two.
Yes, they are. No, they are in parallel, Andrea. That's correct. And we're gonna get to that at one point. But right now we're just looking at the variables that they're giving us. So in this case of these two currents are going to be the same. But yes, these two are in parallel. Now let's look at.
It's a loop.
It's a loop. Correct. Let's look at some of the nodes here. I'm gonna place and again, I'm doing the analysis like step by step and slow, just so we practice again. Maybe if you do one of these exercises, you don't have to do all the steps. You can kind of identify the solution. That's fine. I'm just doing it so it's documented. So let's say I'm gonna call this node A. I'm gonna call this node B, and I'm gonna call this node here C. Now, notice one thing. Yes, yes.
Can you draw the loop, please, in I2 and I3? Or it can be to whatever direction.
No, ahí está los errors.
The loop here would be
arrows.
like this.
Okay. Professor, I have a question. Aren't they like 4 nodes?
Yeah.
We're gonna get to that. I was hearing you guys saying there's 4 nodes, there's 5 nodes. I'm gonna draw them and then I'm gonna erase them. We could say, okay, wait a minute. This is a node, but notice what this is drawn purposefully to confuse.
Okay.
Is there? Let's call this node D just for the purpose.
Okay.
Is there anything in the middle of node A and node D?
No.
So this is these two are exactly the same point. So
So it could be in that point.
the resistor could be connected here like this, and it would be exactly the same thing.
Okay.
Okay. It could even be connected. It could even be connected over here, and it would be the same thing. Okay.
Okay, I see.
And so, yes, go ahead.
Well, the line can go past.
Yeah, as long as there's nothing in the middle between A and D, it's still the same point. What makes something not be a node when it's a branch? In a branch, there has to be something in the middle. A branch is a point between 2 nodes, and there has to be an element in the middle. If there's nothing in the middle of 2 points, then those 2 points are connected together. Okay.
I know, but you said right now that, for example, branch I1, if it goes past A.
This one
Right now
here,
it's before, if it does that, that's still the same.
yeah, because there's nothing here in the middle. There's nothing here.
That counts if we have, like, for example, a current. It can be a current or a resistor, or just a resistor.
Just a resistor. The resistor is the element.
But in that little part in the middle, what direction would the current be going?
It doesn't matter. It's going into this point. It's going.
But the one that's like, if I1 was after A.
It would still be going from A to D. It goes from one point to the other, but the point is connected at the same junction.
Okay.
Now let's analyze the nodes and see what we can find here. And yes.
So if the node can be, like if D was A2, so I1 is going into A.
Exactly. That's exactly it. That's why it's kind of too confused. We would say, wait a minute, let me answer one question before I go to the next one. Let's imagine that that I1 is like this, like you said, Andrea. So it's going into this point, but it's the same point, so it's going into A. Okay, yes, Lisa.
So the current doesn't affect if the resistors are parallel or series.
What do you mean it doesn't?
Like, for example, to determine the nodes, because I was like thinking, oh, A and B, well, I2 and I3 are in the middle of two parallel resistors.
No, but I2 and I3 aren't in the middle. I2, I'm gonna draw it in green. I2 is this one.
But it wasn't.
And I3 is this one over here. They're overlapping. They're exactly the same thing only in this section that I drew. Over here, there's something else because that is in parallel.
And that doesn't count.
No. So now let's look at the nodes and let's see what we can infer from this. Let's look at, I'm going to start at node A, just to go in order. Node A. What is going into node A and what is going out of node A?
I1.
Okay, so we know I1 is going in.
And like a complemented by
We know that I2 is going out, okay? But there's also here this resistor, and we don't have anything there. You notice that?
Yeah.
So actually, there's something here as well. So I1 is going in here.
And I3 doesn't count.
I2 and I3 are the same thing. So there's another current going out, and there's actually another current here.
It will be I2.
Exactly, it has to be the same. Oh, are you okay? Oh, be very careful with because teeth can break. I'm sorry, I wrote I3. This is I1. Why is that current that's going through here? Why is this the same as I2? Can somebody tell me? It's two paths and the resistors are the same. They're exactly the same. So if I have one thing going out and these two are the same, it has to be split equally. Okay. And so if I have I1 coming in and I have I2 coming out, because they're the same, I2 has to also be coming out. Okay. So I1 is going to be equal to I2 plus I2, which is equal to 2 times I2. Okay. Now let's go to node B. I'm gonna write it again, but closer. Okay. Now let's look at node B. What is going into node B? I2 and I3, but we just said that they're the same. So yeah, let's say that well, I'm gonna do it this way. I3 plus I2 equals I4, just to write it down like you guys said, okay? But I3 is the same thing as I2. So this would be the same as saying I3 plus I3, I'm sorry. I2 plus I2 equals I4, which would give us that I4 is actually 2 times I2 as well. Okay. Lastly, let's look at let's look at node C. What is going into node C and what is going out? I4 is going in, and what's happening there? This is going to split. So if this is I1, then what is going I1 as well? So we're going to have I1 plus I1. This is 2 times I1. Okay, so. Yes,
Oh, no, you put that I2 and I3 are going in, right?
yes.
And why?
So here,
Now, like in note 8, you're not putting that I3, it's going out of note 8.
they're the same. I could have said I3 as well. They're this. Remember that we just said here that I2 and I3 are the same.
Ah, okay, okay, okay.
So actually, I'm just using I2 as a reference, but we can use 2 or 3 as we want. From what I just wrote here, can somebody tell me something I can infer?
That I1 and I2 are the
Not I1 and I.
No.
same. That I1 is bigger
Oh, yes,
than
uh-huh.
I2.
Or that I4 is the largest.
Mhm. So we know that I2 and I3 are the same. So of the options we have, which one has I2 and I3? This one? So we eliminate this one. And this one is valid. The rest of the 3 are valid as well. Is I4 equal to I1?
It's bigger.
No, it's not equal. So this one would be eliminated as well. Okay. Which one is larger between I4 and I1? I4 is larger. Okay. I4 is larger. So these 2 are still valid. Okay. Is I1 equal to I2 and I3? No. Is it? Excuse me?
Why in note 8 we don't put like 2 times I1? Because there's 2 currents going into
I want like 2 I1s.
yes, we have I1. 2. Why did we only put 1?
Oh, we're missing one there. That's right. Okay, wait a minute. Before we're missing one there. You're right. Here, yes, you're right. Let me correct node A. Give me a moment. This is correct. In node A, yep, this is correct. Thank you, Alejandro. Yes. So we've got 2 I1s going in, and we've got 2 I2s going out. That's correct. Okay, so this would mean that if we organize this, 2 I1s, it's equal to 2 I2, and the 2's in this case would be eliminated. And this would give me that I1, this is the one we were missing, is equal to I2. Okay, so it should be D. Okay. Because, well, that's one thing, but the other thing is that if I1 is equal to I2 and it's equal to I3, and then you've got this expression here that says that I4 is 2 times I1. So I mean that would make it larger. Okay. So in theory, it should be D. Okay. I'm gonna leave it there so you guys can write that down before I click because it's gonna.
Oh, it's time.
I think. Oh, that's another thing. Wait. That's another thing. I think it randomizes the problems, and I think it also randomizes the answers. So even if you have got a guide right now and are writing down the answers, if you click on it again, I think the answers are also going to be mixed up. Okay, it's designed kind of like a study guide. You can write that down with me.
Está fácil. Tenemos que hacer los notes. ¿Ves? Los notes son importantes. No puedo ver. ¿Cómo que me veo?
Okay, can I scroll down and see the answer? Have you guys written it down?
And probability.
Pero al rato el Ricardo se va a olvidar.
Sí. No, para esto. Espero que no. Es que revisamos en 3 semanas.
¿Creen que nos quedamos en las vacaciones? Yo digo que no.
You're thinking so far ahead, Justin.
Para ser muy sincero.
Yo digo que sí.
En un
Yo digo que
Calimax o
no.
algo así.
Eso no se hace cuando estamos en la escuela, menos cuando no nos vemos.
Pero sí,
Pero la vida es así, no vamos a ver en un
Ay, hace como 2 meses no se ya sé. Pero es que tienen que hacer que los niños tienen los viernes porque están cansados.
¿Y por qué no nos vamos las niñas? Si no lo
Ya,
quieren.
Ricardo dijo que quiere.
Y Ricardo.
De niñas.
Es Juan también.
Okay, so this is from the second grade. The difference between these exercises is that these have numerical values, the others were just symbolic. And again, just to practice Kirchhoff's and Ohm's law as well, which are the concepts that we've been seeing up to this point.
They don't give us the value of words.
Nope.
Ya está dando valor.
But we can assume that it's the same as three. Tiene que ser 5. Tiene que ser 3 más 5,
Primero anótalo. Apenas escribí exercise. Anótalo.
Me compró un pastel de orden.
Ah, no.
Pero, ¿por qué no?
Okay, so these problems have numerical values to them, and again, it's to practice these relationships, but we're giving it a circuit array there. We aren't being given all of the values. Okay, so we have, we don't know the value of the power supply. We don't know the value of R2. We do have a couple of resistors there of 8 ohms and 3 ohms. And so what is the magnitude of the potential difference across R2? Remember one thing, when we're talking about potential difference, that's the same as or equivalent to talking about voltage, okay? So they're asking us for the voltage in R2. So what can we do there to find that?
I have a way.
Well, first off, is there a voltage we can calculate?
Yes.
No.
The one opposing to R2. We labeled it as like.
We've got a 3 ohm resistor there. And we know the current that's going through it, which says it's 2 amps. So here we know that the voltage for the 3 ohm resistor is going to be equal to resistance times current. This is, remember that this is Ohm's law. Ohm's law says that voltage equals resistance to and multiplied by current. And so the voltage in 3 ohms is going to be equal to 3 ohms multiplied by 2 amps. And this is going to be equal to 5 volts. No, 6.
Questioning my math.
No, well, here 3 times 2. Yeah, here 3 times 2 is 5. No.
Professor Sosa says 3 times 2 is 5. I believe him.
I've done that as well, and it's not. There was a person I will not name, but I once I once told the person that the reason, I'm gonna say, part of this is in Spanish, but I said it very seriously. The reason why Arizona is called Arizona is because it comes from a combination that since it's a desert part, then it's obviously a place on earth, it's a zone, and it's very árida. So it comes from árida zona, Arizona. That
It's the
is,
same thing.
that is completely, I believe that's a falsehood. But I said it so seriously that the person was like, oh. Yeah. I think that person mentioned it to somebody else at their work, and so. it's something that's funny
Did you
to-
probably?
I don't know, maybe it is, maybe it is, I don't know, maybe it
And
is.
like the state of Nevada has like, has nieve on the top.
No. Well, one thing that is true, this is true, and I don't know why, did you guys in high school take a course that had to do with history of Baja California?
Yes.
Some of you did.
Yes.
I do not remember a lot of things from high school, but I don't know why I remember that California, the name California comes from Cálida Fornaux, which means place that there's a lot of heat, and it's Cálida Fornaux, and that's why it's California. That's true. That's not, I didn't invent that, but I don't know why that stayed with me. I don't remember a lot of things from high school, but I do remember that. Why, I have no idea. I remember how to sing the Himno Nacional from primary school when they trained us. But I don't remember a lot of other things. I don't know how our brains work, but that's the way it does. And coming back to this, we know that the voltage in the 3-ohm resistor is 6 volts. Now, how is that resistor connected to R2?
Parallel.
In parallel. And we know that if there is a parallel element, then the voltages are going to be the same. Parallel element, the voltages are going to be the same. And so that means that the voltage of R2 is going to be equal to the voltage of the 3 ohms. Yes,
You were correct.
it is?
I can
Arizona?
send you the link.
Really? I really did not know that. I invented that and I thought it made sense, but it is true? Wow.
Existen varias teorías relacionadas con el nombre de este estado.
The theories. So the theories.
Tradicionalmente se creía que procedería de las palabras españolas zona árida.
Wow. Actually, something I invented turned out to be true. Wow.
It also means small spring.
Small spring.
From-
Oh, I'm gonna tell this person then that I was right. So it should be 6 volts. So we know that the voltage in a 3-ohm resistor is going to be equal to the current times the voltage. That times the resistor. That's because of Ohm's law. So it's resistor times current, that's 6 volts. And this resistor is connected in parallel to this one. And in parallel, the voltages are always going to be the same.
So the 8 ohm is useless.
Yes. In this instance.
Yeah, it's a distracting. It's a distracting element.
It's meant to-
I don't like that resistance, but it's wow.
Es el más rico.
Okay, let's jump to the next one. So this should be D.
They all can be.
They've all been D, right? They seem to all be D, right?
So te conocí que me cargas todo.
Okay, I'm gonna jump to the next one.
Depende de la familia de guayabas de la que provenga.
Yo no toco guayaba verde.
Nunca he probado con guayaba.
Más que.
En productos. Me encanta. Me traigo para-
Habla como el gato con botas. Más que.
Okay, now this is can I give you a minute for this one? This is also one where we should remember some things, and we should remember how Kirchhoff's second law works.
Recuerdo más tarde, ok. Bueno, las dos opciones.
Mira, eso es 4. Es 4. 12.
Es 2.
Es 4 por 3.
12. Más 4, 16. Te queda 2 ahora.
Está bien.
No es 13 porque yo me lo estoy anotando. Usted
¿Usted
ya dio los resultados.
Ya lo vi al final del semestre queriendo escribir todas. Ya lo dijo nosotros. Yo le digo, yo pienso que nomás la vi la mitad de esa ronda. Ojalá no seamos esa mitad. No, es ahí. De ahí ya no se pudiera más. Electric potential is voltage.
Yes, remember that, these are or terms that can be considered equivalent. So we're talking about voltage, electrical potential, potential difference, potential drop. All of those are voltages. So we're talking about voltage. Oh, do you guys know
No.
when you're doing by the way, when you're doing a multiple choice exam, a tip when you're doing a multiple choice exam is that if you don't know the answer, you should always answer the same letter. The same, you can choose whichever one you want, but you should always answer the same letter when you don't know the answer. And you guys are industrial engineers. I think you're gonna take statistics next semester, or you're taking it now.
Probability.
Well, probability, so ask about that. If you use the same letter, there's a probability that you will get a certain percentage of those answers correct if you always answer the same letter. Well, but you're not gonna pass if you answer all of them, only the ones you don't know. Okay, it'll give you a better probability
What if
of
the
it.
probability is over 7?
The what?
What if the probability is over 7?
That's a more complicated problem.
Which letter would you pick? C or D?
For this one?
Yeah, I don't know.
Oh, in a letter, I would,
Like if you don't know any answer. C. Maybe, I think that it's always.
which one would I would pick? I don't know, I'd probably pick B or C, I think. B or C, yeah.
Professor, you know, if we don't pass the exam, we need to do it again.
Okay, so let's remember about Kirchhoff's second law. And they're in series, correct? And actually what we have here is that we have this is a loop. I'm gonna call this. It's the only loop we have. So I'm gonna call it loop 1. It's the only one we have, but we're gonna call it loop 1. And oh, you guys really help me out with the volume because my throat really hurts when I start speaking too loud and start coughing. We've got a loop, and remember that in Kirchhoff's second law, the voltages across the loop, the sum of the voltages have to give us 0. Okay, and so what we're going to do is add those up and see what happens, and see if we can get to the answer. Let me move this. So I'm going to call this resistor 1. I'm going to call this resistor 2, and this one is 3, which is the one we don't know about. So let's go around the loop. Let's go around the loop. I'm going to start here. What is the first thing we find if I go here? Correct. It's minus.
Professor, you said that all of the voltages have to be 0.
The sum of the voltages have to be equal to 0. Correct. Excuse me. According to Kirchhoff's second law. Minus 18 volts. Then we're going to find R1, the voltage in R1. I'm just going to write it down here. We're going to substitute it in a minute. And then we're going to find the voltage in R3. R2, I'm sorry. and then the voltage in R3, and all of this has to be equal to 0. Now, remember something that we mentioned when we were doing the exercise of Kirchhoff's second law. The power supplies have polarity. We know that. So if it's going into the negative, it's negative. It's the voltage is going to be according to the sign it's going into. All of the other elements don't have a polarity until we know the values of the current. So by default, we're going to write them down as positive. Okay, so all of the resistors, notice that I wrote down the voltages as positive. That's going to be kind of like a rule. Okay, so of the values we have here, this is going to be minus 18 volts. R1, we can calculate the voltage because we've got the current. These 4 amps are going to be the current that's going to be going through the whole loop because, as somebody mentioned, these are in series. Okay, so the voltage in resistor 1 is going to be equal to 1 ohm multiplied by 4 amps. The voltage in resistor 2 is going to be equal to 3 ohms multiplied by 4 amps. And we've got the voltage in resistor 3, which is the one we're looking for. All of that has to be equal to 0. So we've got minus 18 volts plus 4 volts plus 12 volts plus VR3. This is equal to 0. Minus 18, bless you, plus 4 plus 12. This is going to be equal to minus 2. And so VR3 has to be equal to 2 volts, which, oh, it wasn't A, it wasn't D. Okay. So I'm going to scroll down. I'll put it up again so you can write it down if you want. Just to check the answer, I'm going to select A. It's great work. It's great work. Okay. Okay. Questions with this one? Can I move on to the next one? Are we good? Okay. Okay.
De la nada, tu vida está como que me mata.
Como si fuera villano.
Sí, en el beso de villano. Hacer si la haces. No, no.
So
Ya está.
now
Pero me imagino bien.
No, es imposible. Ay, no. ¿Dónde sacaron eso?
okay. So for this problem, now we've got an array there, and then we've got 3 resistors there. 2 of them we know the values, which is 2 ohms and 6 ohms. We don't know the value of R3. We've got a 15-volt power supply, and they're indicating the current that's going through that section. So let's, there's many ways, by the way, we could solve this one, but I want us again to practice Kirchhoff's law. So question again, just to practice. How many loops do we have in that circle? 2. We've got, oh yeah, 3. Remember the definition. So this is loop 1. This is, yes, this is loop this is loop 2, and remember that we've got a third one, which would we've got more than one. We've got this one here, I'm sorry, we've got 3, but remember that we don't need to use all of the loops. This is just a practice. How many, now, the other question is, how many meshes do we have? Meshes are 2, because meshes can't have loops within them, okay? Now, what I'm gonna do here is the following. I need the voltage in R3. So R3 is in parallel with the 6 ohms, right? So if I find the voltage in the 6 ohms, I'm finding the voltage in R3. Now let's see how we could do that. Well, first off, we are going to, let's try to use Kirchhoff's law here. I know that there's 4 amps going in here, but I don't know the currents, how it's separated. So I'm going to say that there's another current here that I'm going to call this one I2. And there's another current going over here that's called I3. So according to Kirchhoff's law, 4 amps is going to be equal to, in this node, I'm going to call this node A, 4 amps is going to be equal to I2 plus I3 in node.
Will be 4 amps is I1?
Yes. This will be congruent with the colors node. Remember, we don't need to do all of the nodes. I'm just putting here information I'm going to need. So 4 amps is going to be equal to I2 plus I3. Now I'm going to go to loop 1. And in loop 1, I'm gonna do the circuit here. The first thing I'm gonna find is minus 15 volts. Plus the voltage, I'm gonna call this resistor R1. I'm gonna call this one R2. So it's gonna be the voltage in R1 plus the voltage in R2. And this is going to be equal to 0. I know that the voltage in R1, I can calculate that because I have the current. Correct? It's going to be the resistor, which is 2 ohms, multiplied by the current, which is 4 amps. And I don't know the value of voltage of R2. This is going to be minus 15 volts. 2 times 4 is 8 volts plus VR3 equals to 0. That means that VR3 is equal to
este es lo mismo, ¿no?
oh no, wait a minute. Yeah, yes, it's true that they're the same, but you're correct. The one I'm analyzing is loop 1. Yes. Yeah, it's correct. This is R2. I'm sorry. They are the same, but I'm analyzing that loop. Correct. So this means that VR2 is equal to 7 volts. Now, because R2 and R3 are in parallel, I know that the voltage in R3 is going to be equal to the voltage in R2, and that's going to be equal to 7. So in the other ones, all of them were D, and now all of them are A. This is not a well-designed.
And the next one, just answer A without even looking at it.
Let's maybe do that, and maybe it is A in the other one.
Not they have to fix their algorithm.
Yes. It's going to go down to verify. I didn't click it. Okay. Okay. Can I jump to the next one? We'll do. Yes. Oh, of them. That's fine. Excuse me? That's a good question. They're only going to be in the video because they're I haven't been taking screenshots and they're going to be random. And I'm actually doing that on purpose because I want you to jump to the links to do that as kind of like a study guide, but they're going to be in the video.
But they are the same.
The problems are exactly the same. So if you click the link, they're going to be exactly the same problems, but they're going to be in different order. And I think the answers are also going to be randomized, but it's exactly the same problem. Yeah, that's it. That's the idea, that you can use it as a study guide. Okay, let's do this. This is an easy one. No, this isn't. This one isn't A.
Sí, therefore 24. Therefore 24.
Okay, so in this one, we've got two resistors that are connected in series. There's only one loop. And we've got a power supply there. And they're asking what is the potential difference, or what is the voltage in the battery or the power supply. So, and we are given the current. So basically what we have here, we've got one loop. And so if we go around the loop, we're going to find the voltage we're looking for, that they're calling it delta V, plus I'm going to call this R1, I'm going to call this R2, the voltage in R1 plus the voltage in R2, this is going to be equal to 0. I know that the voltage in R1 is going to be the resistor times the current, so it's going to be 2 ohms times 3 amps, plus the voltage in R2 is going to be the resistor, which is 6 ohms times the current, which is the same 3 amps. That's going to be equal to 0. Oh, by the way, it's minus delta V because we're going through the negative. So minus delta V plus 2 times 3 is 6. 6 times 3 is 18. So this means that delta V has to be equal to 24 volts. So in this case, it would be, or it should be C. It wasn't, no. Still seems to be a bad randomization.
Everyone did the same except for that.
Okay, so let's see. I'm going to scroll down to check the answer. Oops, I need to check it first. It would be C. Oh, and again, if for any reason you got it wrong, this is the complete answer. This is just in the problem, it's going to give you a hint. It's not going to give you the complete solution. Once you select it, if it's wrong or if it's right, it's going to give you the complete solution. Okay, questions with this one? Okay.